Here we're asked to solve a linear system that consists of 3 equations and 3 unknowns. Let's begin by eliminating the variable y. Now we can do that with equation 1 and 2 if we multiply both sides of the first equation here by 7. And that'll leave us with this equivalent system here, where y is lined up to eliminate. Adding these equations together, we have 28x minus 6z equals negative 24. Now let's eliminate y again using equations 1 and 3. And here we can line y up to eliminate if we multiply both sides of the first equation by negative 3. Now, adding the equations of this equivalent system, we're left with negative 14x plus 3z equals 12. This leaves us with a system of 2 linear equations with 2 unknowns, x and z. Now, to solve this system, it looks like we can eliminate x if we multiply both sides of the second equation here by 2. And when we add the equations of this equivalent system, we can see the variable x eliminates, but so does the variable z. And that leaves us with 0 equals 0, which is a true statement. That tells me the original system is a dependent system. And so we'll choose to express the infinitely many solutions in terms of x. Let's begin with the second equation here. Negative 14x plus 3z equals 12. We can express z in terms of x if we solve for z. In this case, we'll add 14x to both sides. 3z equals 14x plus 12. And then dividing both sides by 3, we have z equals 14/3 x plus 4. Now we have z in terms of x. Next we need y in terms of x. To find that, we'll use the first equation here in the original system. And so we have 7x plus y minus 2z equals negative 4, in which we'll substitute z here, 14/3 x plus 4. This equation will allow us to solve for y in terms of x. Let's begin by distributing this negative 2. And that leaves us with 7x plus y minus 28/3 x minus 8 equals negative 4. Now 7x minus 28/3 x is minus 7/3 x. And then minus 8 equals negative 4. Now adding 8 to both sides, we have y minus 7/3 x equals 4. And then finally y equals 7/3 x plus 4. So at this point we have y in terms of x and z in terms of x. We're ready to present our answer. Now our infinitely many answers will take the form x comma y, which we found was 7/3 x plus 4, comma z, which we found to be 14/3 x plus 4. So any ordered triple of this form where x is a real number will solve the original inequality, or the original linear system.